Have you ever wondered about the mysteries of Uranus, the icy blue planet that spins sideways and boasts some of the most unique features in our solar system? Did you know it's often called the odd one out among planets due to its strange tilt and frigid atmosphere? Join us as we uncover 10 incredible facts about Uranus that will change how you see this enigmatic giant. Trust us, you won't want to miss this. Uranus spins on its side. Uranus has one of the most peculiar rotations in the solar system. Unlike other planets that spin upright or slightly tilted, Uranus rotates almost completely on its side with an axial tilt of 98 degrees. This means it essentially rolls along its orbit, creating some of the most extreme seasons imaginable. Each pole experiences 42 years of constant sunlight followed by 42 years of darkness as the planet orbits the Sun. Scientists believe this unusual tilt resulted from a massive collision early in Uranus's history. A protoplanet or asteroid likely struck Uranus with enough force to knock it over, leaving it spinning sideways. This collision may have also contributed to the planet's faint ring system and its strangely aligned magnetic field. The sideways spin isn't just a curious fact, it dramatically affects Uranus's atmosphere and weather patterns. Winds swirl in bands perpendicular to the equator, creating unique cloud movements. Observations from spacecraft and telescopes show shifting patterns of methane clouds, hinting at complex dynamics beneath the serene blue appearance. Uranus's tilted axis challenges our understanding of planetary formation and evolution. Studying it offers insights into how cosmic collisions shape the solar system and influence the development of other celestial bodies. It's the coldest planet in the solar system. Despite being farther from the Sun, Neptune is not the coldest planet in the solar system. Uranus holds that title. The average temperature on Uranus plunges to a frigid -224 degrees Celsius, making it an icy giant in every sense of the word. This intense cold results from Uranus's lack of internal heat. While other gas giants like Jupiter and Saturn radiate significant amounts of heat from their cores, Uranus does not. Scientists speculate that the collision responsible for Uranus's tilt may have also disrupted its core, preventing it from retaining or generating heat. The planet's atmosphere consists primarily of hydrogen, helium, and methane. Methane absorbs red light, giving Uranus its striking blue-green hue. However, beneath this tranquil appearance lies a chaotic mix of clouds and storms, with wind speeds reaching up to 900 kilometers per hour. Understanding Uranus's extreme cold could provide clues about the processes that govern heat distribution in other ice giants and exoplanets. It serves as a natural laboratory for studying the outer limits of planetary climates and atmospheres. It has a unique magnetic field. Uranus's magnetic field is unlike anything else in the solar system. Most planets, including Earth, have magnetic fields that are roughly aligned with their rotation axes. Uranus's magnetic field, however, is tilted at an angle of 59 degrees and offset from the planet's center. This strange alignment creates a lopsided magnetosphere that twists and changes shape as Uranus rotates. The magnetic field's behavior is so erratic that it resembles a wobbling top rather than the steady fields observed on other planets. This unique configuration likely arises from the fluid motion of electrically conductive materials deep within Uranus. The magnetic field also interacts with charged particles in the planet's vicinity, creating stunning auroras near its poles. Unlike Earth's auroras, which are neatly confined to the polar regions, Uranus's auroras appear in unexpected locations due to the erratic nature of its magnetic field. Studying Uranus's magnetic field helps scientists explore how such fields are generated and sustained. These insights could improve our understanding of planetary magnetism across the cosmos, including on distant exoplanets. It has rings too. While Saturn is famous for its majestic rings, Uranus also boasts a ring system, albeit much fainter and more mysterious. Uranus has 13 known rings, composed primarily of dark particles that reflect very little light, making them difficult to observe from Earth. These rings are believed to be relatively young, possibly formed by the debris of shattered moons or captured material from the planet's surroundings. The inner rings are narrow and dense, while the outer rings are more widely spaced and faint. The Epsilon ring, the brightest of them, contains large chunks of ice and rock. Voyager 2 provided the first close-up images of Uranus's rings during its flyby in 1986, revealing their intricate structures. More recently, Advanced telescopes like the Hubble Space Telescope and the Keck Observatory have offered new insights into the composition and behavior of these enigmatic features. Uranus's rings are a reminder that even seemingly quiet planets have dynamic histories. Understanding them sheds light on the processes that govern ring formation and evolution, not just in our solar system, but in planetary systems across the universe. Its moons are named after literary characters. Uranus's 27 known moons have a unique naming tradition. Unlike other planets whose moons are often named after mythological deities, Uranus's moons draw their names from the works of William Shakespeare and Alexander Pope. Titania and Oberon, the two largest moons, are named after characters from Shakespeare's play A Midsummer Night's Dream. Miranda, another major moon, is named after a character from The Tempest. Other moons like Ariel and Umbriel take their names from Pope's poem The Rape of the Lock. Each moon has its own unique features. For instance, Miranda is one of the most unusual moons in the solar system, with giant canyons, cliffs, and varied surface terrains that suggest a violent history of geological activity. Ariel and Umbriel, on the other hand, show smoother surfaces, hinting at different evolutionary paths. This literary naming tradition highlights the creativity of astronomers and adds a cultural touch to the study of Uranus. The moon's diverse characteristics make them fascinating targets for future exploration, offering a glimpse into the complexity of the Uranian system. Uranus's weather is wild and mysterious. Uranus's serene blue appearance hides a world of chaotic and intense weather. The planet experiences some of the most extreme winds in the solar system, reaching speeds of up to 900 kilometers per hour. These winds whip through the atmosphere, creating massive storms and turbulent cloud formations. The weather is driven by the planet's unusual tilt and distant location from the sun. With such little sunlight reaching Uranus, scientists are puzzled by how its atmosphere generates such strong winds and storms. The lack of internal heat only adds to the mystery, as there seems to be no significant energy source to power the weather systems. Observations by the Hubble Space Telescope and Voyager 2 have revealed bright spots in the atmosphere, believed to be massive storms. These storms can span thousands of kilometers and last for days or even weeks. Methane clouds, which reflect sunlight, often mark these turbulent areas, making them visible to distant observers. Studying Uranus's weather patterns provides valuable insights into atmospheric dynamics in distant worlds. It also offers a fascinating glimpse into how planets with minimal sunlight and internal heat can still produce complex and unpredictable weather systems. It was the first planet discovered with a telescope. Unlike the anciently known planets visible to the naked eye, Uranus was the first planet discovered using a telescope. In 1781, astronomer William Herschel identified Uranus while surveying the night sky. At first he thought it was a star or comet, but further observations revealed it to be a new planet. This discovery expanded our understanding of the solar system and marked the beginning of modern astronomy. It was the first time in history that humans realized the solar system contained more planets than those known since antiquity. Herschel initially wanted to name the planet Georgium Sidus, or George's star, after King George III of England, but the name Uranus was eventually adopted to maintain consistency with mythological naming traditions. The discovery of Uranus also spurred advancements in telescope technology and observational techniques. Herschel's pioneering work laid the groundwork for future discoveries, including the identification of Neptune and the countless exoplanets we study today. The story of Uranus's discovery is a testament to the power of curiosity and innovation. It reminds us that every breakthrough starts with a simple question and a willingness to explore the unknown. Its orbit takes 84 Earth years. Uranus has one of the longest orbits in the solar system, taking 84 Earth years to complete a single trip around the Sun. This means that a single Uranian year is longer than a human lifetime, and each season on Uranus lasts for about 21 Earth years. This extended orbit creates dramatic seasonal changes, especially given the planet's extreme axial tilt. During its long journey, one pole is pointed directly at the Sun for decades while the other is plunged into darkness. As Uranus moves through its orbit, the poles gradually swap positions, leading to unique shifts in weather and atmospheric dynamics. The slow orbit also makes Uranus a challenging target for study. Spacecraft like Voyager 2 had only a brief window to observe the planet during its flyby in 1986. Future missions will need to account for the vast distances and long travel times required to reach and explore Uranus. Uranus's orbit reminds us of the diversity within our solar system. Its extended journey around the Sun offers a perspective on how planets experience time differently, highlighting the vastness and variety of our cosmic neighborhood. Its interior is full of hot ice. Beneath Uranus's cold exterior lies a strange and exotic interior filled with what scientists call hot ice. This unique state of matter is created under the extreme pressures and temperatures found deep within the planet. Hot ice forms when water, ammonia, and methane are compressed to such high densities that they remain solid even at incredibly high temperatures. This exotic material behaves differently from regular ice, conducting heat and electricity while maintaining its solid structure. The presence of hot ice may explain some of Uranus's unusual properties, such as its magnetic field and internal structure. The planet's core is believed to be relatively small, surrounded by a vast mantle of these icy materials. Unlike Jupiter and Saturn, which have metallic hydrogen in their interiors, Uranus's composition reflects its status as an ice giant. This classification sets it apart from its larger gas giant neighbors. Studying the interior of Uranus could unlock secrets about the formation of ice giants and the role of exotic materials in shaping planetary evolution. It also provides a glimpse into the strange and wonderful possibilities that exist in the outer reaches of the solar system. Voyager 2 is the only spacecraft to visit Uranus. To date, NASA's Voyager 2 remains the only spacecraft to have visited Uranus. During its historic flyby in 1986, Voyager 2 provided humanity with its first close-up look at this distant ice giant. The spacecraft revealed Uranus's faint rings, dynamic atmosphere, and mysterious moons, transforming our understanding of the planet. One of the most surprising discoveries was the planet's lopsided magnetic field, which added to the intrigue surrounding Uranus's internal structure. Voyager 2 also captured detailed images of its moons, revealing complex terrains and geological activity that were previously unknown. The data collected during this brief encounter continues to fuel scientific research today. However, the flyby lasted only a few hours, leaving many questions unanswered. Scientists are eager to return to Uranus with a dedicated mission that could orbit the planet, study its atmosphere, and explore its moons in greater detail. Voyager 2's journey to Uranus represents one of humanity's greatest achievements in space exploration. It serves as a reminder of how much we can learn from even brief encounters with distant worlds and inspires the next generation of missions to explore the unknown. And that concludes our journey through Uranus, a planet that defies expectations and captures the imagination. From its sideways spin to its mysterious interior, this ice giant is a testament to the wonders of the cosmos. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep reaching for the stars with us.